we first got the Hot Wheels video racer, we thought it was fun to see first person how the cars were going through the loop track. In my son's excitement as we watched the videos over and over and over, he had made the comment that the cars were going so fast. So the question we'll investigate is, how fast is the car going?
When I set out to adapt this idea into a possible lesson, I used the ideas from the SimCalc technology noted in the Hoyles articles as a springboard. I wanted to try and address the concept of slope through multiple representations and connect the verbal or narrative to the graphical, the tabular, and the algebraic expressions. And then not only that, add in the motion phenomena, and that's where the Hot Wheels video racer comes in. With the Hot Wheels video racer, we could see the motion phenomenon and connect that to the slope. In addition, I also wanted to try and address what students already know from 6th grade science. They know how to calculate and have seen the formula for average speed. The students that I have worked with in particular have seen a graphical organizer, such as this one, to show that speed is equal to distance over time, or distance could equal speed times the time. So one of the things I might wanted to try and address is to connect a meaning to this graphical organizer. But that may end up outside the scope of this presentation. To set up the track, I placed an 8-foot piece of wood underneath the Hot Wheels track to maintain a constant slope throughout the 8 feet. Then I placed blue tape on the track at the beginning and at the end so that we may be able to identify the start and stop points on the video. We then marked off 1-foot increments along the wall, up to 5 feet, to help the person holding the track. The video eraser comes with a USB cord to charge and then to transfer your videos. The video eraser itself has its on-off switch on the side, and then when you're ready to record, just hit the button on the top. Once it's red, it's ready to record. To gather the data, I used Movie Maker so that I could slow down the video frames and identify the start and stop times. I'll drag my file from the desktop into Movie Maker, and then I'll hit play until I see the first 2 blue tape. So here's the first blue tape, and that went way too fast, so we'll back it up, and we'll back it up to where we see the first blue tape, and I'm going to keep going forward until I see it move forward. So there I can see there's forward movement, so I might mark 5.62 as my start time. I'll hit play, and then we'll back it up again till we see the blue tape. So I might say 7.85 there. And if I subtract those, we'll get 2.23. So it took 2.23 seconds when my height of the track, of the start of the track, was 1 foot. So to get all the other pieces, I would just keep going through the time trials. Now the possible disadvantage of using Video Eraser and Movie Maker is that I have to use this program in order to identify my time trials and slow down the video frames. However, if we take a look at our technology standards, we might actually be addressing some of the technology operations listed here, particularly understand and use technology systems and select and use applications effectively and productively. So it just depends on your perspective as to whether or not using the Video Eraser and Movie Maker is an advantage or disadvantage. For each of the 5 track start heights, I collected 2 trials. I took the average in time in seconds, and then I found the average speed in feet per second. So recall that the length of the track was 8 feet, so I just took 8 feet divided by the time in seconds. I also went ahead and converted my feet per second to miles per hour for each of the track start heights. Here, we've already calculated and answered the question, how fast is the car going? So I thought I might extend this further by comparing the picture of the slope of the wood plank to the speed of the car. I had hoped for some kind of correlation to the slope of the function from the TI Inspire app and compared that to the speed in either miles per hour or average speed in feet per second. So moving to the iPad, I can open up my TI Inspire app. To create a new document, I would hit the plus. I've already started one, so we'll use that document. I've already imported the first 4 heights, so I'll go up to the plus sign, hit graphs, go to my camera, and we're going to add the last slope. And I'm going to move this down to the bottom. So now to move the origin, I use 2 fingers to pinch and zoom. I can zoom in and zoom out. And I'm going to move that origin down to the bottom of the plank. From here, I can then add in a function. I'll hit X and then enter. And the TI Inspire app allows you to rotate that function, so then we can rotate it until it matches the slope. So I try to get it as close as possible to the bottom of the plank. So now that I've done that for each of the different heights, for 1 I have 0.089, 2 0.23, 3 I have 0.37, 4 I have 0.55, and then for 5 I have 0.77. And I have that listed in a table here. So in my investigation, I was not able to find or really determine what the relationship was between that. I'd hoped to find something other than these numbers increase just like these numbers increase, which was what expected. So I wasn't able to find anything else. So I thought, since I have a track height and a speed in miles per hour, I thought I might go ahead and use those numbers and plot them, and then maybe extend that even further. So I'd go to my plus sign and we'll hit a list and spreadsheet. I'll go to the A to name that height. So I'll name that height. Then I'll go to the B and name that speed. So I can hit 1, 2, 3, 4, and 5. And then in my speed, we had 2.46, 3.69, 4.70, 5.93, and 6.07. So now we can go back and add a data and statistics page. I can select here on the left hand side to have my speed, and then select down here my independent variable, select my height. So I can see that it looks like it's linear except for this point. We can also add a regression line in here. We might add the linear and the quadratic, and then maybe have a discussion on which function might be a better representation to predict the speed. So to add the regression line, we'd hit the wrench, then we can select the show linear. We can go back to the wrench again and select the show quadratic. If we're able to determine whether the linear or the quadratic is a better predictor, we then might be able to utilize the video eraser at Six Flags possibly, as students are going down the first drop of a roller coaster, then hopefully maybe verify. We wouldn't be able to do top speed, but maybe the average speed going down that first drop, using the information here, and then having that video eraser strapped to the wrist of someone going down. So that could be fun. Using the video eraser from the video eraser strapped on their arm, we can try and calculate the average speed and then compare it to the predictions using those regression lines. So it could be interesting, and I hope to investigate that further. So I don't think I was able to set a viable, ready-to-go lesson, but I have plenty of questions and ideas to continue to investigate from the video eraser and coupled with the TI Inspire application. So thanks for watching.